Bueno, hola a todos y todas, vamos a ir empezando y supongo que en unos ratitos más se irá conectando el resto. Bueno, muchas gracias por venir a este webinar. Mi nombre es Laura Bonofiglio, soy parte del Grupo Strep que coordina Laura Vigliarolo. Y bueno, antes de empezar y presentarles a Lucy, les quería compartir pantalla para contarles unas cositas. Un minutito mientras vamos esperando al resto de la gente. Em, Aprovecho la oportunidad de que muchos de los que están acá trabajan en hospitales y demás, y les quería contar que nosotros desde la Facultad de Farmacia y Bioquímica, algunos de ustedes ya lo saben, hicimos un estudio multicéntrico de infecciones por Streptococcus agalactiae en el año 2014-2015, recibimos un montón de aislamientos de hospitales de todo el país, así como lo ven acá marcado en este mapita, y realizamos la caracterización fenotípica, genotípica, hicimos la secuenciación del genoma completo y hemos mostrado los resultados en distintos webinars y congresos que ustedes ya conocen. El motivo de esto que les estoy contando es porque en este año vamos a lanzar un nuevo estudio multicéntrico, luego de 10 años del anterior, entre los años 25 y 26, y en esta ocasión nos vamos a encargar de recolectar Streptococcus agalactiae tanto de portación, de neonatos e invasivos. Entonces, van a empezar a recibir algunos emails quienes ya hayan participado, en algunos necesitamos actualizar los contactos, así que si alguno de ustedes quiere participar o conoce a alguien que le interese participar, para nosotros es muy importante porque, bueno, cuanto más representado esté el país es mejor para tener información actualizada sobre este microorganismo. Y ahí les dejo mi email como para que me manden un mail y me digan quiero participar y nos ponemos en contacto. Así que eso. eh, Ahora les voy a dar paso a Lucy. Para mí es un placer, hablé con Lucy que yo la presentaba en castellano. Es un placer que Lucy esté acá con nosotros y que pueda dar un seminario para ustedes. Ella trabaja en Streptococcus agalactiae y le va a contar un poquito más de su perfil. Ella viene de la Universidad del Oeste de Australia, University of Western Australia, trabaja en Streptococcus agalactiae, también trabaja en fagos y bueno, gracias a un proyecto conjunto que tenemos, está de visita en Argentina, en Buenos Aires, en nuestro laboratorio, y como parte de las actividades que está haciendo, bueno, la invitamos a que dé un seminario nos cuente un poquito de qué pasa con Grupo B, Streptococcus agalactiae, en Australia. Así que, it's all yours, Lucy. Hi.
Gracias. Hello, everyone. I hope you can hear me okay. Thank you so much for having me. It's a real honor to be able to present to you today a little bit about Group B Streptococcus, colonization and infection. I'm really happy to be in Argentina. It's been amazing. I'll just introduce myself a little bit at the start and then talk a little bit about Group B Streptococcus from an Australian perspective. So this is where I live in Perth, which is in the western side of Australia, so pretty far away. I'm a research fellow at the University of Western Australia and I work at the main maternity hospital there. So we focus on perinatal microbiology, really interested in infection during pregnancy and early life and focusing on women and babies. But we have a focus as well on preterm birth and other initiatives spanning across the world. This little animal is called a quokka, and if you're using any bioinformatics, that was the inspiration for PROCA. So this is a bit of an introduction of the scope of research that we do. So ranging from very clinical focused research and diagnostics, and then other things such as like more basic science and understanding the mechanisms underpinning certain scientific relationships, for example, bacteriophages and Group B Strep. But this is across the full spectrum of pregnancy and early life. So postnatal, antenatal, prenatal, looking across all aspects there. Why am I here? You might be asking, you're probably asking. So this is a really great opportunity. Thanks to Laura, it's been amazing. We've been able to get to know each other and realize that we're working on really similar areas that are so complementary So I've just got a slide here, just giving a bit of background as to why we're working together, and a little bit of background as well, looking at the places that we're from. So very different population size, and a very different sort of, but very similar attitudes towards research and where we want to take this to prevent infection. I just wanted to highlight the team here in Buenos Aires, the University of Buenos Aires, and thank them all. So Vero for her expert bioinformatics skills, Mario, who's not here right now, but here in spirit and will be coming to Australia, and Chiara. So yeah, a big shout out to them and the amazing research that they're doing. But I'm here to work on a project together looking at Group B Streptococcus and the prophages that are within them. So I am really grateful for the opportunity to speak to you all today, and I hope we can get to know each other and keep building collaborations between Australia and Argentina. So today I'll be going quite broad and looking at a scope across just what GBS is and the focus on pregnancy, looking at carriage, infection, a little bit about treatment and some of the areas of resistance that are emerging, and then more about the research that we're doing at the moment, trying to refine our aim and a move away from this broad approach of treatment. So to start off, Streptococcus agalactiae, I'm sure you know this is Microbiology Society, so you're probably well aware, and Laura is an expert to have here with us, so it's funny to be presenting. But we are looking at an organism that really preys on the vulnerable. So meanwhile, it can be commensal and, you know, in healthy adults, but it often will cause disease in the immunocompromised and elderly, but it has multiple hosts. So this is a really fascinating aspect of Group B Strep, in that it can actually colonize and infect a range of different hosts. And here are just a few examples here. Cows, fish being the main sort of focus, but, you know, spanning all the way to camels and alligators. But the focus of this talk today is really the perinatal period, and the focus on it being the leading cause of neonatal sepsis. And this is mainly through the genitourinary colonization of pregnant women. So transmission, how does it cause infection? Well, this is a really simplified view of a colonized mother, so vaginal or rectal colonization, and this can lead to an ascending placental and uterine infection in the womb, or more commonly transmission during delivery and passage through the birth canal. But depending on the invasiveness of the strain, this can lead to penetration of the blood-brain barrier and cause meningitis, bacteremia and sepsis, or pneumonia and lung injury. So it's really severe outcomes for these babies and newborns. And this is why we're really focused on trying to understand this bacteria. But this is a very simplified view. But in reality, I really like this image because from Bianchi and Jasur, that really highlights the many pathways that Group B Strep colonization can lead to healthy delivery and no issues, but it can also have some really devastating impacts on the neonates, and that's why we're so interested in trying to understand this more. So looking at antenatal screening, I'll be coming from a bit of a global perspective, but then highlighting what we're doing in Australia. Antenatal screening is mainly risk-based or universal screening. So these are the two main approaches. Risk-based is all about looking at the different risks we might have. So fever, preterm birth, ruptured membranes, bacteriuria, or if you've had previous GBS disease. But there are a number of limitations with these, especially if it's your first pregnancy and you don't have any history. This can be a detrimental part of risk-based screening. Universal screening, on the other hand, will go based on a swab result, so vaginal and rectal swab around 36 weeks gestation, to look for presence of Group B Strep. And this could be culture or molecular screening or both in some cases. And this will see if GBS is present or absent and determine whether prophylactic antibiotics are necessary. So any risk factor or a positive GBS screen will lead to antibiotics given a minimum of 4 hours before delivery. And this has been quite a big sort of debate or cause of conversation in terms of what approach should we take? Should we be looking at the universal screening or risk-based to reduce the incidence of Group B strep disease? And there's been a lot of different approaches to this research, but I like this systematic review that found that overall universal seemed to be slightly better than risk-based in reducing the early onset GBS disease. And the main concern with universal screening is the thought that we might be over prescribing antibiotics because of the colonisation, but actually similar rates of antibiotic administration were observed across the two. Universal a little bit higher, but nothing significant. Looking globally, this is sort of a map that shows in the dark red the microbiological screening, so more of that universal approach, and you'll see Australia follows that, similar to Argentina, but risk-based is more common in the UK, New Zealand, and other parts of the world. So we're not all on one page, but you know, we're working towards doing it in whatever way suits that country. This is a really old figure, but it's a classic one that demonstrates the impact that guidelines can have on reducing disease. So this is showing with the arrows each of the implemented guidelines and the impact they've had on early onset disease, so within the first 7 days of life. And this, I will also note that you can see in the dashed line, late onset hasn't really been impacted by this, and this makes sense because it is looking at intrapartum antibiotic prophylaxis, so the idea of the transmission and the vertical transmission rather than late onset being often a nosocomial or other transfer of infection. So it makes sense, but we still need to focus on reducing those rates even lower. In Western Australia, where I'm from, and where I've been focusing the majority of our research, we do universal-based screening for GBS between 35 and 38 weeks gestation by culture. So we have recently been looking into more of molecular and the rapid screening intrapartum, but at the moment still culture is the gold standard for us. So if they're positive, then they'll go on to receive intrapartum antibiotics. But if they're negative, then no other action. So this informs the result and the antibiotics before delivery. What antibiotics are selected and used? So penicillin is the go-to antibiotic, but we know that we have penicillin allergy. This is the biggest reason why you might change the course of action. And GBS susceptibility is also a big factor now, and we're testing for that more and more. I think we were getting quite complacent about GBS and the susceptibility to most antibiotics, but we know that clindamycin resistance rates are rising, and I'll show a little bit more about that in a second. So we're screening all pregnant women that come through our maternity hospitals, and we're getting this result of positive or negative. And this is around 10 to 30% of women that will be receiving antibiotics because of GBS colonisation. And so at the time that we were looking at this, we saw this as a big opportunity to be able to actually get some more information. It seemed as though we were doing a lot of work to achieve this result, but not gaining much more that we could work to refine this treatment. So we found it was an opportunity in Western Australia to start to get some information, because we were really not, there was really not much information about Group B strep in Australia at that time. So we were looking at a doing a cohort study. This was part of a bigger preterm birth cohort study. So they were prospectively recruited at the second trimester, so around less than 22 weeks gestation, and then at the third trimester, around 33 plus weeks gestation. And these were self-collected swabs. They would do their standard hospital swabs as well. This was a separate swab taken, and we looked at culture results, and we also developed a multiplex PCR that looked at GBS detection, and then 3 of the main serotypes we were interested, 1A, 1B, and 3. So as I mentioned, it's a sub-study of a cohort study looking at preterm birth outcomes. This is just a few of the members of the team that are interested in this space, but we were really leading the GBS part of this project, and it was around 2015 to 2017 that the recruitment was happening. So it was a temporal analysis, and this was able to allow us to see individual swabs. We did individual vaginal and rectal swabs taken over the 2 time points so that we could look for differences in the colonization of the site of the sample as well. So in general, from a diagnostic point of view, we compared the hospital screening versus our own study screening. So we used carrot broth and chrome and also PCR, whereas the hospital used limb broth and granada. So we found that we actually had non-hemolytic isolates, which are often very rare and not really considered that much, but we did find that we had non-hemolytic isolates. So this is something to consider when you think about granada. Also, carrot broth we found was really specific, but doesn't detect the non-hemolytic isolates. That's why we were interested in having that approach with the chrome agar as well, but it wasn't as specific in terms of that. So looking at the Group B Strep colonization, so we wanted to know the temporal dynamics. So what happens at visit 1 versus visit 2? Are they still colonized? Have they lost colonization, gained colonization? Because this will help us to understand what the best point of screening is. We often will screen ideally later towards term to try and get the most accurate result, but some women will deliver before they've even had their screen. So what's the best approach? And we wanted to know if this was similar in our population. So overall, GBS colonization rate that we found was 24.9%, visit 1, 24.7%. So very similar rates. But breaking it down into the individual samples per gestation, we found that there was around just under 90% were consistently either colonized or not colonized with Group B Strep. So their result remained the same regardless. This is great, but that also means that roughly 10% had some transiency. So they were positive at one screening, but negative at the other, and vice versa. This is interesting because we want to know if this is true transiency. We know that this bacteria can fluctuate in terms of its bacterial load, or if it is a matter of screening and some issues with maybe low bacterial load or maybe a difference in sampling. These are all self-sampled, but we found that it was pretty consistent and we were happy with the sampling. But this is something we're interested in to try and unpick how we can best screen and what's happening in terms of the actual interactions with colonization. So why were we so focused on colonization? Everybody's probably thinking, well, great, but what we want to know about infection and preventing infection. But I think colonization was really understudied at that time, especially in Australia. There was really not anything on colonization. And this is this gives us insight into disease, because we know this is the point where invasive infection can be transferred. Oops. So another aspect of this study, given that we separated all of the swabs individually and we tested them all individually rather than the pooling approach that the hospital would use, we had an opportunity to look at the different serotypes. So Group B Strep has a capsule that gives it a different serotype or capsule type. And so there are 10 different capsule types. And we wanted to see if these were the same per site, so vaginal versus rectal, or if they differed at all. And so we found that there was co-colonization. You can see in the red where they were different at each site. So maybe they had a capsule type 1A in the vagina and then 1B in the rectum. So this, I think, is one way that really highlights that it's not so clear-cut how GBS is colonizing, and maybe the one colony that we select, and this is an issue we have in microbiology for all of the ages, but the one colony or the few colonies may not be representative of the other isolates in that are present. But we found this was really interesting because when we think about surveillance and thinking about vaccines, this could be something to consider in terms of serotypes. So the screening outcomes, as I mentioned, overall we had about a quarter of all pregnant women that were screened with GBS positive, and this was sort of on the higher side in terms of globally. So the global rate is around 18%, so it's a bit higher than that. And we had looked at the different demographics as well, but I'm not going to speak about that, but happy to talk to anyone that's interested. We sequenced a subset of these isolates, and I've just got a phylogenetic tree here that demonstrates with the different colours the clonal complexes that we found. So Group B Strep is very clonal, and you can see that because you're getting all of these really nice groups here. But WA, Western Australian isolates clustered mainly into the 4 major clonal complexes, 19, 12, 17, and 23. And we had 27 different multi-locus sequence types or STs that were in our data set. So we included vaginal and rectal isolates, antenatal carriage mainly, but a few neonatal disease as well. Here I've just highlighted the 10 neonatal disease isolates that we included, and you can see that there's no real clustering for the invasive isolates. They were found pretty much across all of the clades there. We compared this at the time to whatever is in the Pubability database, and so definitely not representative of the whole global data that exists now, but it was a nice way to have a look and see what's happening with other isolates. But you can see that there's a bit of a bias between majority of African isolates there, and a lot of these were invasive isolates as well. But I think the majority, I guess the take-home message here is that in black we have the Australian isolates, and you can see them scattered across the tree as well. So they're just clustering with their other clonal complexes. But this was just to put it into perspective of where we're sitting, or if we had a very different lineage compared to globally. This is just a graphical representation, so looking at Bayesian analysis, higher BAPs, to see what the different recombination between the clonal complexes was. And so the take-home message here is that, so where you're seeing the different colours and the lines within each coloured block is where there is some recombination observed across different clonal complexes. But you'll notice that in the 2 blue sort of colours, CC19 and 17, we didn't actually observe any recombination based on this higher BAPs analysis, which we found quite interesting. Clonal complex 17 being associated with the most severe sort of invasive disease, hypervirulence. So, as I mentioned, beyond carriage, the neonatal isolates were scattered across the tree. but this was only 10 isolates. So at that time, that was what we had available, but we were really interested understanding the carriage. We wanted to then look at the neonatal invasive disease in Western Australia as well. So this is a study that we did together. So Ginger led this as the medical student leading the project, which was really great. We had 135 GBS isolates, neonatal invasive, early onset, late onset, and stillbirth across 2004 to 2020. So this was a back catalogue retrospectively looking at every GBS isolate we could sort of find in the diagnostic freezers and having a look at those, doing phenotypic testing, so antimicrobial susceptibility testing, D-tests, penicillin MIC, and then also the genotypic testing, so looking at the whole genome sequencing to understand that as well. As I mentioned, we've got a few different sort of disease states, so early onset, late onset, and stillbirth. And this was not to say that that's the number of early onset cases in that year, but this was what the samples we had that were available that we included across the time points. So the biggest take home here is the rising resistance. So we did phenotypic testing here and then also looked at the genomic side of things, but we didn't see any resistance to penicillin, but we did see an elevated penicillin MIC, so just greater than 0.12 milligrams per litre. And you can see that over the time points, we've just categorised time based into the 3 sort of blocks. And you can see that that was rising over the time that these isolates were collected. Similarly, really stands out the erythromycin, which most people would be aware about. Erythromycin is not recommended for treatment anymore. You can see why. It's around 45% of isolates that are resistant, but clindamycin also is becoming very much that way as well, and mostly in more recent times. So we were really interested in this because there is a bit of a complacency around Group B Strep and the susceptibility, but I think we're seeing that change a lot too. And just to mention 22.5% inducible clindamycin resistance by the D-test as well. So these are all invasive isolates. So a little bit of a warning there. I wanted to put this into context because we recently had a report from the Australian-wide AURA, we call it. So it's an antimicrobial resistance sort of surveillance. This is passive surveillance, so labs will send in data just based on the data pulled from the system, and looking at erythromycin in the purple colour and clindamycin in the green. So you can see that over time, from 2006 to 2023, we're seeing rising rates of resistance, which is exactly what we found as well. But this is looking at all of Australia and understanding that. What I was mostly interested in here is this figure. So I saw this when I was reading it and I thought, oh, because penicillin resistance is very rare. There's a few case studies, but we're not really seeing it being reported as in great numbers. But I noticed in this, the percentages are very, very small, but they indicate that there are penicillin resistant GBS isolates. So I'm chasing this up now to understand where they're coming from, if this is an accurate representation of strains being resistant to penicillin. But if this is the case, then I'll definitely be wanting to look into where these are coming from and what testing is done. As I mentioned, it's a passive surveillance, so it's just data being pulled, so we'd have to do a bit more digging around that. But this is a very respectable resistance report, so we're really interested in that because this could be a bit of a concern. And this is backed up by the World Health Organization looking at priority pathogens. So they had clindamycin-resistant Group B Streptococcus until recently. So 17th of May in 2024, they upgraded this to a medium group, and it was the penicillin-resistant Group B Streptococci. So this is another layer of support to show that resistance is becoming more of an issue when it hasn't been for a long time. So what can we do about it? I'm not really going to talk about vaccination, but I think it should be mentioned, and this is a big focus and would be a great area for prevention of Group B Streptococcus. And so this all relies on the maternal vaccination to transfer the maternal antibodies to the newborn or to the fetus. And then if the antibody levels are present at the appropriate level, then this would ideally provide protection against Group B Strep in a window of that pregnancy, late pregnancy and into infancy. The vaccine targets have really been focused a lot on the surface receptors and the capsule polysaccharides. So here we've got the capsule, and as I mentioned before, there are 10 different capsule types. These can vary geographically, so there's some capsules that are more so associated with different regions, but often the case is that all capsule types can be found within populations, but they're important to understand the epidemiology and the different targeted therapeutics like vaccines. So we were looking at this from a vaccine perspective, looking at our serotype distribution in our population, what vaccines would be, what coverage these vaccines would potentially have. Obviously, the bivalent and the trivalent were the earlier vaccines where they only had a few targets, but the sort of leading candidate, the hexavalent, so 6 different capsule targets would be ideal. The more you can cover, the better. And so we found with our population that I just mentioned in terms of the carriage, around 93% would be covered by a hexavalent vaccine just based on the capsule type. But I always like to highlight that we do have other what are considered rare capsule types, and these wouldn't be covered by the vaccine. And we know that this is important to consider, especially in surveillance and understanding implementation of these types of vaccines, because you can see serotype replacement, as we know for meningococcal, for example. Looking at the invasive disease, we can see that this actually covers a bit higher, so 96% of the invasive GBS would be covered, but we still have presence of these more rare capsule serotypes that wouldn't be covered as well. So something to consider when we're thinking about vaccination and how we can maybe approach this from a multifaceted way. With that, I just want to touch a little bit on some of the work we're doing with bacteriophages and our interest in this, and sort of why working together with Laura about Group B Strep and phages. So the idea is that we could improve our aim. So using antibiotics has a sort of broader stroke approach, and we'd like to refine this so that we can be highly specific and targeted to only remove Group B Strep. So this is an opportunity where we are only targeting one organism and we're preventing this infection. So bacteriophages would be an ideal solution because they're highly specific and could have less impact on other commensal organisms. So Group B Strep phage isolation is not so straightforward. I've just listed some of the main studies that have looked at isolation or have isolated these from the environment. So this is our study in 2020 that looked at wastewater. So we were isolating different phages here against Group B Strep. But you can see that people have looked in aquaculture perspectives and bovine mastitis as well. This is just a quick summary of the activity that our phage had against the antenatal carriage isolates that I mentioned and the neonatal invasive disease isolates the 10 that I included in the phylogenetic tree. And so we've got a broad coverage when we look at it as a whole. So very specific and individual host range individually. But when looking at it from a cocktail point of view, using maybe all of the phages together, we could get about 77% of the antenatal isolates that would be susceptible to at least one phage. So obviously lower than our prospective vaccine, but it could be a nice way that we complement each other. But all of the phages to date have been temperate. So this means that they have a lysogenic module and they have the ability to integrate with the bacteria and potentially not kill them, which would be the goal of therapy. So as with anything we like to do, it's not so straightforward, but it makes it very interesting to understand why is this the case. So many other organisms have lytic phage that can kill them and are very common. Group B strep is quite difficult to isolate bacteriophages against and only has temperate phage that have been found to date. So why is this? And I'm really interested in this space and understanding colonizing the colonizer. So this multi-layered approach of bacteriophages and prophage with their interaction with Group B strep and how that might impact the clinical situation. So with that, I will just summarize a little bit about what I spoke about. So Group B strep is the leading cause of neonatal sepsis. So it's a really big issue. And as I mentioned, we have limited options for suitable therapy during pregnancy, and resistance is definitely emerging and at an increasing rate, it seems. So definitely something to be looking forward to thinking about other options for therapy or prevention, because we have an opportunity to prevent GBS disease, and I think this is a really exciting avenue. Understanding the different capsule types and surface proteins are really important for making sure that we can implement those future therapies in a way that is suitable for the population, understanding the individual populations and what they need, and understanding if they're actually effective. So future strategies, we're really interested in bacteriophages as a future therapy, but understanding that these could be perhaps an ideal solution for understanding the cause of infection as well. So we want to really focus on achieving this for the families so that we can prevent Group B strep infection. So next steps. This is just a little bit of a highlight of my time in Argentina so far. And I think what I'm trying to get to with this slide is that collaboration is key. We met and realized we had very similar approaches and aiming for the same thing. So ideally, let's work together. Let's make sure that we can achieve those results quicker and have a more holistic view so we can bring these together. So I just wanted to say that, yeah, building the collaborations more broadly and going beyond, you know, our labs, we can have much more impact together. And it's been really exciting seeing all of the work that's happening in Argentina. I think it's great. With that in mind, the reason that I'm here today is because I met Laura at ISAD. So this is a Group B Strep conference. That was my first time attending in 2023, and it was amazing. It was in Brazil, and it was a fantastic conference. And I just thought I'd add this here because it was recently announced that the next ISAD will be in Nairobi in Kenya in 2026. So if you're interested in Group B Strep, I think that would be a great conference to attend, and we can build out collaborations more broadly there to prevent Group B Strep disease. It's a great conference. So with that, I would like to just acknowledge all of my collaborators, the funding we've received, and a special thanks to all of the study participants, because without them, we can't do this research and we can't help other people find the answers that they need. So they're the most important, I think. So with that, I would like to say gracias and thank you so much for having me. I'm so sorry that I'm asking for questions in English, but yeah, happy if you want to contact me via email or social media, always happy to chat and happy to answer any questions that you might have. But thank you for listening.
Muchas gracias, Lucy, por tu seminario. La verdad que fue muy interesante y, bueno, vuelvo a agradecerte que estés acá, que hayamos tenido la oportunidad, como bien contaste, de estar acá. No sé si alguien tiene preguntas, que las escriba en el chat, algo que quiera comentar o preguntar. Me di cuenta que estoy hablando en castellano, perdón. Thanks, Lucy. I am asking to the people if they have any questions to ask. That feel free to write in the chat. So I don't know if you are. No sé si están acá, si siguen acá, veo que están en el chat. Yes. Esperen que me están mandando preguntas por acá. Bueno, buenísimo. Si alguien tiene alguna pregunta para hacer, me dice. Si no, mientras tanto, yo tengo alguna preguntita. Well, in the meantime, that people trying to think about one questions, for me, it was very interesting the study that you did when you study the antenatal colonization, yes, between the 22 weeks of pregnancy and the typical, no? That my question is about why did you think before doing this, no? This study that you will found, or which was your hypothesis, no? About doing, because I think it's very interesting because you, well, maybe you were thinking about that the intermittent colonization or something like that. So if you want to tell us more about that. Sorry about my English, it's like this, but Lucy knows how to speak. I speak.
Yeah, no, that's great because we'd found in the literature it had been mentioned a lot of this transient sort of colonization and intermittent colonization. And I think this stems from it being a gut colonizer and yeah, moving out from there. But it just, for us, it wasn't very clear what the reality was here and if it was something that we could actually target and understand a little bit more about whether that was the case for all populations or all sample types. So that was the main reason behind looking at this. Obviously, as well, from a preterm birth perspective, trying to get an earlier answer would be ideal. But if it's not really going to change treatment, you know, there's pros and cons for that. Because if your membranes rupture and you're giving birth preterm, then you're probably likely to receive prophylactic antibiotics anyway. So there's sort of this discussion around that, but understanding a little bit more about colonization. But we were interested as well. So we have a PhD student at the moment looking at changes in the microbiome, not during pregnancy, but during the menstrual cycle, and looking at this and understanding that a little bit more. So we're interested to see from that perspective as well the influence of hormones on Group B Strep over time and really pulling out the Group B Strep in those samples. So it's something that we're continuing to work on to understand what the mechanisms are and why this is the case, because I don't think it's very clear still. And trying to understand if it is worth pursuing, like what information this brings. But yeah, that's an area of interest for us, for sure.
That's great. Great answer. I don't know if someone has a question. Las pueden hacer en castellano también si quieren. Anímense, aprovechen para preguntar algo que les haya interesado de la charla, de fagos o de esto que contó ella sobre colonización. I also, if nobody asks questions, I could ask another question. I am also interested in the distribution of serotypes that you found. and the data you obtain, because it's very important that near the future we will have the vaccine. As you said, it's important to continue monitoring because all the serotypes, most important serotype, will be included in the vaccine, the new vaccine, but maybe we will observe after years, no, of the improvement, the replacement serotype. So are you planning to monitor again or continue monitoring the epidemiology, the serotypes of Group B?
Yeah, that's a great point, because that's why we're really interested in having this baseline. So before this study, we really didn't know anything about it. There was a big focus on invasive disease, but there wasn't really anything about carriage. So we were one of the first studies that found serotype 9. So just to understand that even is really important to have that baseline, but that also then sets the foundation so that now, okay, if you screen again, you've got something to work with in terms of understanding any changes in the epidemiology. And I completely agree that we can't really know what we're targeting if we don't have that sort of surveillance data. I don't know, it all comes with a cost analysis. So you know, the limited funds in terms of healthcare funding will determine how widespread that is, but we have the samples that are coming in routinely, so it's a great opportunity to be able to keep the surveillance going. It's not like we would have to specifically sort of recruit for these samples. So I think it's a really good opportunity that we can keep some sort of surveillance going. So we're looking at doing some more Australia-wide multi-centre studies here, just to get a bit of an understanding of what's happening now. And this is ongoing, so we're really excited to see that. But I'd love to hear more about what's happening in Argentina in that space as well. We can learn from each other.
Great, Lucy, thank you. There's a question here. Cecilia Pandolfo sent to me in private, and she said, did you use any enrichment medium for the rectal samples?
Yes, so for the hospital uses limb broth, but we use the carrot broth for the enrichment and then played it onto chrome agar. So yeah, definitely we did try looking at sample to molecular testing. So we did straight sample extraction to look at our PCR, but we found that obviously enrichment was ideal. But I think it did highlight that the road of molecular testing, if you're pretty time poor, is a great opportunity. But yeah, we always miss something if you don't enrich. But yeah, rectal samples we treated the same as vaginal. We just processed them separately so we could understand if there was much of a difference there or if they were colonized at both sites.
Great. I don't know if there are, well, Cecilia say thanks. I don't know if there are any other questions, and if not, we could wait one second because we have time. Well, if not, I would like to thank you again, Lucy, for being here. For me, it was a great opportunity to share with you and to stay with you again. Well, I hope that we will take new results together to show to our country and your country and being together again. Si alguien más tiene alguna preguntita, tenemos 2 minutos más, y si no, bueno, les agradecemos la presencia en este seminario. Y bueno, cualquier cosa le escriben a Lucy o me escriben a mí, que ya tienen los contactos ahí a disposición. Muchas gracias, Lucy.
Thank you so much, everyone.